Hello everyone. In this video we're going to be going over related rates question for calculus. Number 1 asks, water leaking onto a floor forms a circular pool. The radius of the pool increases at a rate of 4 centimeters per minute. How fast is the area of the pool increasing when the radius is 5 centimeters? So we're always going to try to figure out three things before we start the question. First, what were we given? What do we want? And what is our condition? When what is happening? So first, we're given that the radius of the pool is increasing at a rate of 4 centimeters per minute. So that means that the derivative of radius with respect to time is going to equal 4 centimeters per minute. They want to know how fast is the area of the pool increasing, what is the change in area with respect to time, when the radius is 5 centimeters, when r equals 5 centimeters. So we want the derivative of a with respect to time. They give us the derivative of r with respect to time when r equals 5 centimeters. So we're going to start off with the formula for area of a circle, which is pi r squared. If we were to take the derivative with respect to time, we'll get that dA over dt equals 2 times pi times r, and then times the derivative of r with respect to t. Here we're using implicit differentiation to take the derivative of our variables. We're looking for dA dt. So dA dt equals 2 times pi times r, which is 5, times dr over dt, which is 4. 2 times 5 is 10. 10 times 4 is going to be 40 times pi. And since we have dA over dt is 40 pi, the units is going to be centimeters squared per minute to represent area over time. Number 2, oil spilling from a ruptured tanker spreads in a circle on the surface of the ocean. The area of the spill increases at a rate of 9 pi meters squared per minute. How fast is the radius of the spill increasing when the radius is 10? First, we're going to write what we're given, then what we want, and then our condition when. We're given that the area of the spill is increasing at a rate of 9 pi meters squared per minute. This is going to be the derivative of area with respect to time is going to equal 9 pi meters squared per minute. They want to know how fast is the radius of the spill increasing. So they want to know dr over dt when the radius is 10. So when r equals 10 meters. So we're going to start off once again with the equation for area of a circle, which is going to be area equals pi r squared. We're going to take the derivative with respect to time. dA over dt equals 2 times pi times r times dr over dt. We found that dA over dt is 9 pi, so instead of dA over dt, we're going to have 9 pi equals 2 pi times r, which is 10, times dr over dt. We're going to bring this up over here. This is going to simplify to 9 pi, which equals 2 times 10, which is 20 pi, times dr over dt. Finally, to get dr over dt by itself, we have to divide both sides by 20 pi. On the right side, the 20 pi's cancel, and we're left with dr over dt. And on the right side, the pi's cancel, and we're going to have 9 over 20. And since we have dr over dt, this is going to be the measurement of the radius, which is meters, over the measurement of the time, which is minutes. So 9 over 20 meters per minute. This is the rate that the radius is changing. Number 3, a conical paper cup is 10 centimeters tall with a radius of 10 centimeters. The cup is being filled with water so that the water level rises at a rate of 2 centimeters per second. At what rate is the water being poured into the cup when the water level is 8 centimeters? For this question, we're going to set up what we are given, what we want, and our condition. It says that a conical paper cup is 10 centimeters tall, so that means h equals 10, and the radius is 10 centimeters, so r equals 10 centimeters as well for the whole paper cup. The cup is being filled with water so that the water level rises at a rate of 2 centimeters per second. So this means that our h is changing. dH over dt is going to equal 2 centimeters per second. We want to see what rate is water being poured into the cup. So water is being poured into the cup at a volume. So this is going to be the change in volume with respect to time. This is what we're looking for when h equals 8. So we're going to start off with the equation for volume of a cone, which is going to be volume equals 1 over 3 pi r squared times h. From the question, they tell us that the height is 10 centimeters and the radius is 10 centimeters. The objective here is for them to tell us that h and r are the same. The proportion of them will also be the same throughout the conical paper cup. So no matter what, h is going to equal r. The way we know what we're going to replace is what the question's asking for. They also give us dH over dt. They want to know when, at what point the change in volume will be when h is 8 centimeters. So it looks like we're replacing r with h. V equals 1 over 3 pi. Instead of r, we're going to write h squared times h. This is going to give us 1 over 3 times pi times h cubed. Now that we have our equation, we can take the derivative of both sides. The derivative of volume is going to be dv over dt. And this is going to equal, when we take the derivative of the right side, we're going to end up with pi h squared times dH over dt. They're telling us that dH over dt equals 2. So we'll have that dV over dt equals pi. H is going to be 8 squared times 2. dV over dt equals 8 squared is 64 64 times 2 is going to be 128 pi. And we have to remember the units. This is dv over dt. So it's going to be our measurement of length cubed, centimeters cubed, divided by our measurement for time, which will be seconds. And I'm getting this from the question, centimeters per second, centimeters, centimeters. And this is the answer for number 3. For number 4, a spherical balloon is inflated so that the radius increases at a rate of 2 r centimeters per second. How fast is the volume of the balloon increasing when the radius is 4 centimeters? So we are given that dr over dt, the rate at which the radius is changing, is 2 centimeters per second. I think this r is a typo. Sorry about that. We want how fast the volume of the balloon is increasing. So we want the change in volume with respect to time when our radius is 4 centimeters. We're going to start off with the formula for volume of a sphere, which is volume equals 4 over 3 pi r cubed. We need to take the derivative of each side. The derivative of volume is the derivative of volume with respect to time. Here, when we take the derivative of r, we're going to multiply by 3. We're going to end up with 4 pi r squared times dr over dt. Here we can plug in everything we're given in the question. So dv over dt equals 4 times pi times r squared. R is 4. So 4 squared times dr over dt, which is 2. 4 squared is 16. 16 times 2 is 32. 32 times 4 is going to be 128 times pi. Since this is dv over dt, we need to make sure we're putting the right units. This would be centimeters cubed per second. If you learned something new in this video, please make sure to smash the like button and subscribe to the channel for more math content like this. If you want to make sure that you pass the AP test or you're in college taking Calc 1, follow my channel so that you get more tips and tricks on how to improve your grade. I'll see you in the next one.